Yeah, you should spend a lot of time on these videos. Since they are completely unmonetized, you need to watch me do math for free. No commercials.
Paid to watch
I would say no interruptions, but sometimes there are students. Just kidding. It's a joke. It's a joke. Here, do these guys have a common base? No. So we should give up, right? No. Why not? What should we do?
The logs come to our rescue.
What was that? No, what did you say we should do? Well, we can't see, because 2 and 3 can't be forced to have the same base. So it's not like 4 and 8, which could have a common base of 2. This is where you do the log of both sides. So I'm going to do the natural log because that's what all the cool kids are doing these days. Yeah, of course. They're also driving really boxy-looking pickup trucks. So now what? I took log of both sides. For what purpose?
So you can bring the terms that are now your power to the front.
Right, so this is going to be x plus 5 times natural log of 2 equals, on the other side, I have 2x times the natural log of 3. Now this isn't like the last problem that we did where I could just divide by natural log of 2. Because I've got x on both sides now, right?
Yep.
This is going to be a bit of a problem, but we can easily manage this. What you want to do is distribute. So x natural log of 2 plus 5 natural log of 2, and we just bring down the right side of the equation. We've seen problems like this before, not exactly like this, but when you have x in 2 different spots and you're trying to get x by itself, anything that has that factor needs to be on one side of the equation. If you don't contain x, you need to go away. And so the way that we can do this is to just put everything on the same side, and I'm going to choose to move the x natural log of 2 term from the left to the right. And the reason I'm choosing to move in that direction is because this is the only constant term that I have. So let him stay on the left side of the equation. He's like the Duke boys, never meaning no harm. Now on the right side, you've got these 2 logarithmic expressions. They both contain x, but they can't combine because one is a 3 and one is natural log of 2. So it stays this way. But there was a trick that we played a couple of weeks ago where these guys have a common factor, right? And what we were able to do back then is that we were able to factor this common factor out. So now we have 2 natural log of 3 minus the natural log of 2. So I go from having 2 instances of x to just having the 1. And so how do I get that x completely by itself?
Divide by that big factor.
Well, it's just because it was bone structure. So I divide both sides by that factor, 2 natural log of 3 minus natural log of 2, and do it on both sides. Right? And now you know me, I like to write my x on the left side. I have 5 natural log of 2 over 2 natural log of 3 minus the natural log of 2. This is exact. If you can get here on the test, I'm going to be thrilled. But I want more.
Kind of like that big fat there.
No, this is how relationships go. I always want more, right? I need the approximation. Let's make sure that we can type this into the calculators correctly. And this is where we usually have a lot of problems. My suggestion to you is open up your parentheses. You know, you can do this. Open and close. I better not. Before you do this, in this expression, I want you to make some notes. I want you to say you've got big parentheses on the top and on the bottom. I want you to do that. And then, for each of these logs, I want you to use a different color, so put parentheses around all of these guys right here. And that's what you're going to be looking for whenever you type this into your calculator. So I've got the big blue parentheses right here. 5. The natural log gives me a set of parentheses, so I don't need to do another one. 2. Close off the log. Close off the numerator. Are you with me on that? Divide by, and you have to open up a set of parentheses for the denominator because you've got a big thing down here. And that's 2 natural log of 3. Close that natural log. You're still in the denominator. Minus natural log of 2. Close the natural log. Close the denominator. And so we end up with an approximation of 2.304. You can check this by doing 2 raised to the 2.304 plus 5. I get some crazy decimal. If I do 3 raised to the 2 times 2.304, oh, what did I do? You see that these decimals are really close to each other. They're close to 158 for both of them. So you know that you're kind of on the right track there, just by plugging them in and checking them.